Yeah, so magnetic fields haven't changed much since you did them in year 11, but we'll look at a few different ones. So the first one you should remember is just a simple bar magnet, and if we have a north and south, we then do the field lines as these loops. So there's large loops going around like that. And remember, if you had a north pole sitting here, it's going to be pushed away from the other north pole, so the arrows always leave the north pole and go in at the south. So we use a little north pole test pole. The next one is using two magnets. Like so, and these field lines are repulsive, so they're actually not going to cross. They join if they're attractive, they push away if they are repulsive. So these ones are all going to push away from each other like this. And so on. And in this region there'll be no magnetic field. And then if you have it again, but this time south there, north there, then the lines actually combine. And so on. And include all the rest. There's some good notes, good pictures in the notes. The next one you need to remember is a current carrying conductor. So if we had a current flowing up this thing, I, in that direction, then it creates a magnetic field around the wire. The magnetic field around this wire is going to be circular in nature. Okay, and it gets weaker as it goes out, so it's actually going to have a larger distance between the lines as it goes out. Okay. The direction is given by your right hand grip rule, so if you put your thumb on the wire, okay, showing the direction of the current, then your fingers are going to rotate around the wire and it shows the direction the magnetic field is going. Okay, so in this case it is going around this way. If we look down on the wire, like this, if it's across means it's going away, dot means it's coming towards us. So you can go down and you can find that this one is going around that way, this one is going around that way. If we extend on that and we combine heaps of wires in a circle, okay, so we make a solenoid like this, and we're going to now chop it in through the middle, and it looks like this. So we have wires looping around, and we're going to look at the ends of the wires. If this was going into the page, the current, this one was coming out, then each of these are going to create their own magnetic field. In this case, if this one's coming out, then it's going around this way. If this one's going in, then it's going around that way. And all of these are going to do the same, so they're all going to combine to create the same, a combined magnetic field line that goes through, and they all go the same direction. So that actually makes it a lot stronger. How do you find the north and south pole with a electromagnet? So let's say there's an iron core. Remember, for an IG we use iron cores because it's not permanently magnetized. Okay, so let's wrap a wire around this core like this. Okay, we put a current in there. Same sort of thing with your fingers. You sort of wrap your fingers over the solenoid in the direction of the current, and then of your right hand, and then your thumb points towards north. So in this case, this end is north. And that's very similar to what we did down the bottom here. Okay, this end is north because the current's flowing around just like that top solenoid.